In this lecture, we are going to learn about constants in C. Now, this is a sample program that I have already created called as constants.c. Let me create some variables, integer variables a, b and c here. Okay, and let me write an expression a equals to b plus 3 here, and let me assign b as 16. Okay, so I'm trying to do 16 plus 3. In this line number 9, the expression a equals to b plus 3, b is a variable, a is a variable and 3 is a constant, right? Now this constant 3 is by default, it will be a signed constant, signed integer constant. Now I can actually perform this addition and display it, it will work fine. Okay, I'll just write printf a equals to %d and then the answer is a. So now if I try to compile this gcc constants.c and then I run this program a.exe, so I get a as 19. Okay, so this works fine. Now what if I would like to make this constant as unsigned constant? By default it would be a signed constant, right? So in order to make this 3 as a unsigned constant, I need to suffix this 3 constant with u. It can be capital caps lock u or a small u, okay, whatever is fine. Okay, now if I just compile this, there's no issue, right? And now this 3 will be treated as a unsigned number 3, unsigned 3. Okay, by default if I do not write u, it will be a signed constant. Okay, now it has become an unsigned constant. You have to suffix by u or u. Okay, so this is how you do it. Now the constants can be displayed in terms of decimal, in terms of hexadecimal and in terms of octal as well. Now if I would like to display this particular answer, that is a, which is 19, in terms of octal, then I just need to do here is I need to write %o for displaying in the octal form. I'll just display it here in 2 lines. Okay, I'll display decimal in a different line and octal in a different line. So let me say decimal a equals to %d will give me a decimal value, and octal a equals to %o in that case. And similarly I can write hexadecimal a is %x for hexadecimal, %x for hexadecimal, %o for octal. Okay, so let me compile this code now here and let's run this. So I see decimal 19 is octal 23 and hexadecimal 13. This works fine. Now let me assign b as 0, 1, 2. And let me write c is equals to b plus 3. Now let me display what is the answer. C equals to %d. Let me display in terms of decimal. So I write %d. Okay. And the value is c. Okay. So let me try to compile this first and then run this. So I'll see the answer is 13. But how come 12 plus 3 is 13? 12 plus 3 should actually be 15. Right? So a very important thing you need to note down here is, if I write any constant prefixed by, if you look at this, this is prefixed by 0, then it becomes octal constant. Okay, it becomes an octal constant. So this is octal 12 plus 3. So octal 12 plus 3. So let's try to display b first of all in terms of decimal. Okay, so I'll write b equals to %d, and if I write b, let's see what I get it, and let me print this in terms of octal as well. B equals to %o, so this is b, and then let me write here as octal and let me write here as decimal. Okay, let's compile this code and then run this. You'll see b is 1010. Okay, b is 10, so this is decimal 10. Okay, and in octal it is 12. So this is also decimal. By default the constant would be a decimal constant. So decimal 10 plus decimal 3 is decimal 13. Okay, this is decimal 13. So answer is given in decimal. If I want to print the answer in octal, I can also do it. I can just do it like this. I can write c equals to %o. So here I'll get the answer in octal. So I'll just write octal c, and this one is decimal c. So let's try to verify this once. Compile this here and then let's run this. So this is 15 in octal and in decimal it is 13. So I hope you are clear how to actually make or how to actually create an octal constant and how to create a hexadecimal constant. So for hexadecimal constant you have to prefix by, let's say I create one variable, let's say let me create a new variable, let's say e. So I create int e, let this be a hexadecimal constant. So I'll just write int e equals to 0xff. Okay, so this is, I have to prefix by, here I have to prefix by 0x. Okay, if I want to make a number as a hexadecimal constant. So this is a hexadecimal constant I have prefixed by 0x. So I can just print here, printf, the variable is e. So I'll write the decimal e equals to %d. So I'll print the decimal version first. So for printing the decimal version, I'll just write the variable name e, and I'll print the hexadecimal format of this. Hexadecimal e equals to %x. Remember, for hexadecimal the format is %x, and then I write e. So let's compile this first and run this. So you see, variable e is having hexadecimal ff, which is equivalent to 255 in decimal. So this is how the integer constant work. Now if I want to make a constant to be a long integer, let's say I have long int x equals to 1 2 3 4 5. So by default this would be a integer, but if I want to make this as a long int, this is a simply integer, okay, signed integer. If I want to make it as a long int, I have to write L here. So this becomes a long int constant. If I want to make unsigned long, okay, if this is unsigned long, let's say unsigned long int, then I have to write the number, and then I have to write ul. Okay, so just note down, if I suffix by ul, it becomes unsigned long, okay, constant, and if I suffix by simply L, it becomes signed long int. So this is how it works. So U for unsigned int, L for long int. So if I want to make unsigned and long together, you have to write UL. So I hope integer constant is clear now. Let's talk about the character constant now. Let me comment this entire thing here. Okay. Now we already know that character is represented within a single quote. Let's say I create some variable a, and let me assign a value a equals to m. So this is a character m stored in the variable a. Now this becomes a character constant. This m in single quote is a character constant. We already know how to print this, okay? Using the %c format specifier, we can actually display this. Now let's say I'd like to display a quotation. I write life is beautiful. I'd like to display this quotation here, and I just run this code, compile this first, and then run this. The message life is beautiful is displayed as it is, but I want it to display the double quotes as well. Okay, I want this printf to display the double quotes as well. So I want to display life is beautiful inside double quotes. So I can give double quotes here like this. Let's see what happens. If I just do it like this, save the program and compile this, it is saying that, there's an error in line number 28. So because it will be confusing for the compiler, because double quotes, whatever is inside the double quotes is treated as a string constant. Okay. Now if I want to display the double quotes, then I have to use something called as the escape sequence. Okay. Escape character or escape sequence. Okay, there's a specific escape sequence for printing a double quote. So that is backslash. You remember backslash n is for new line. So I have to write backslash n for new line. Similarly, I have to write backslash double quotes if I want to print the double quote. Okay, so wherever I would like to print, so here I would like to print a double quote, so I have to write backslash double quote. Okay, and again I have to print a double quote here, I have to write backslash double quote. So it's very simple. If you look at this whatever is highlighted right now would print life is beautiful inside double quotes, and these two double quotes, they are outside of this life is beautiful. This one and the corresponding closing one, this one, is actually enclosing the string life is beautiful, okay, having the double quotes. So if I try to run this here, compile, okay, I think I didn't save my program, compile it again and then execute it. So I see life is beautiful inside double quotes. So this is how you actually print double quotes. Similarly, let's say I would like to print a backslash. I would like to print backslash hello. I'd like to print backslash hello as it is. Okay, so what happens? So let me give a new line also here. Okay, slash n. Okay, now let me also give a new line here, slash n. Okay, so if I run this now, let's see what happens. Compile this. Okay, now if I compile this, you will see that there is error here, there's a problem here. because it is highlighted here red in color also. Okay, now if I have to write something inside double quotes, if I write backslash, that will actually mean that it is a escape sequence. So escape sequence will always start with a backslash, So compiler will try to understand what is this backslash h escape sequence. There is no such escape sequence available, backslash h, right? In fact, I am actually trying to print backslash as it is. So if I want to print backslash as it is, I have to write backslash 2 times. Okay, so if I just do this here, and if I just compile it now, you will see, I think the semicolon is missed here. I have to give a semicolon. Okay, compile it again and then execute it. You will see backslash hello is printed here. So to print a backslash, I have to have backslash 2 times. So these are escape sequences. This is considered as a single character. Like you have a character A inside a single quote. Similarly, escape character or escape sequence is also considered as a single character. Okay, that is a thing to be noted down. And there are many escape characters like let me try hello backslash t world. Okay, now how many escape sequences I have in this particular print in line number 34? One is backslash t. Backslash t will print a tab number of spaces, and this will print a new line. Okay, so there are 2 escape sequences here. Let me try to compile this here first of all, and then exe, you see hello, and then here I get this space. This is a tab space. Okay, so you have seen this tab in your keyboard, right? So whenever I write any statement, if I write printf hello here, okay, now if I give a tab here, let's say at the beginning of line number 35, I'll give a tab. So tab is this many long spaces. Let's say here 4 spaces. So 4 spaces is equivalent to tab. So a tab will be printed here. That many spaces will be printed here. Okay, these are the escape sequences, or also called as character constant. This is also character constant. It is considered as a single character. Okay, now all these characters also having the ASCII code. So let me try to print the ASCII code for a new line character. So ASCII for a new line character is %d, and I'll give a new line here. So instead of this %d, I have to print the ASCII of new line. So I'll give inside this character constant. So I'll write backslash n, that is a new line character, also called as line feed. Okay, so let me compile this, and now you see that it is 10. So 1010 is the ASCII code or numeric code for the new line character or the line feed. So this is all about the character constant. So I hope character constant is clear to all of you. Now let me just comment all these lines, and then let's now talk about something called as floating point constant. Let me create one variable float, let's say x comma y. Okay, and let me write x is equals to 1.2 plus y, and let me write y here as 12.3. This 1.2 in line number 41 is a floating point constant. It is a constant, right? It's a real constant, right? By default, any decimal point value will be treated as double. So 1.2 is of type double. By default, it will be treated of type double. Okay, so it is actually adding a double 1.2 with y, which is actually made as float, but y is assigned a value. This value is also treated as a double. Okay, so if I have to forcefully make this constant as a float, I have to suffix this with f. So suffix with f or small f to make double into float. Okay, so by default it is double. If I write f here, it becomes a floating point constant. So all floating point constant will be suffixed by f, or you can write small f also, whatever is possible. Okay, so this will now be treated as 1.2 as floating point number, not as a double. So this is how it works. Let me now display this. Let's say x equals to %f, and it is x. Okay, so let's see what is the output here. Let me just compile this and then run this. So I'll get the answer as 13.5. Okay, this is a float value. Okay, so this is all about how constants are represented. We have talked about integer constant, character constant, and double constant. Also long constant, unsigned int constant. Okay, Now let's talk about the string constant. We have already seen this string constant. We have already seen a printf like this, wherein we have displayed hello world in one of our first C program that we have written down. Okay. Now whatever comes inside double quotes is a string constant. Here, hello world and the new line character. This is escape sequence new line character. Now this entire thing is coming inside double quotes, so it is called as a string constant. So here, hello, and then there is a space, and there is world, and then there is a new line character. So this is what? It's a string constant. Okay. Now this is a string constant. Now string is nothing but it's a collection of characters. If you look at this, H is a character, E is a character, O is a character, this space is also a character, okay, then W is a character, O, R, L, D and exclamation mark, all of these are characters. Even this \n is also a character. So I can say that string is nothing but collection of characters. Okay, so we are having a dedicated chapter for strings. Okay, it will come later on. There we will be talking about strings in more details, but as of now you can understand that string is collection of characters. So with this note, we are going to end this lecture. I hope you have learned about constants in C. That's all in this lecture. Stay tuned.